Hey kids, welcome back to some more science, some more kitchen chemistry science, because kitchen chemistry science is cool. In this lesson, we're going to continue our journey through the kitchen. We're going to take a look at yet another item in our kitchen that is made using chemistry. I have here in front of me a plate of something. What could it be? It looks like a plate of rocks. It is not a plate of rocks. I've got crystals here, really big, beautiful crystals that I found when I was on my vacation to the sea. What did we find near the sea? Especially if you're in Bon Air. Well, these are salt crystals. Salt comes from the sea. Now, some salt comes from the sea that already still has water in it, and some salt we get from mining under the ground where there used to be seas, but now it's way down under the ground. Either way, salt is a very important ingredient in our kitchen. And although eating too much salt is not good for our health, you do need to eat some salt. Salt is a very essential part of our diet. But we don't use salt like this to do our cooking. We use salt like this. That's a salt we use. This is called table salt. But table salt isn't the only kind of salt out there. Table salt, sea salt, which is a bigger salt, and kosher salt. These are all different kinds of salt. In this lesson, we're going to learn about where salt comes from. We're going to learn how it gets turned into this kind of salt. We're going to learn about the different kinds of salt I have here, although there are other kinds. We're going to do a little taste test and a little visual test. And we're going to watch some movies about salt. And finally, you're going to bake some dark chocolate sea salt cookies. So, let's get started learning about salt. Salt is cool and science is cool. Let's start off our lesson with a few videos on where salt comes from and how it's processed.
Why do we need salt? Salt is a mineral that is found naturally on planet Earth. Most of the salt on Earth is found in the oceans and seas. In fact, there is so much salt in seawater that if you were to extract it all and sprinkle it over all of the dry land on the planet, the salt would be 35 meters deep. Salt can also be found deep in the earth, in places where ancient seabeds once were. And salt has even come to Earth on meteorites from space. All living things need some salt to survive, including human beings. Salt helps us regulate our body temperature, which is very important, as well as helping to control how our muscles and nerves work. Salt is so important that some of the oldest roads in the world are salt roads, meaning they were built to transfer precious salt to places where there was no natural source. The Via Salaria in Italy, for example, is an ancient road that has been used to carry salt from the Adriatic Sea to Rome for thousands of years. Animals that eat meat get some salt from their food, as all animal tissue contains salt. Plant tissue contains salt too, but not nearly as much. This means that animals that only eat plants need another source of salt in their diets. So these animals might visit a salt lick, which is a place where there is a natural deposit of salt and other minerals, such as spring water coming from a crack in a rock. With that in mind, can you guess what these elephants are doing? When people first discovered these strange scratches on the walls of this cave, they had no idea what could have made them. The answer to the puzzle turned out to be some very clever elephants. The elephants can't get enough salt in their diets from the food they eat on the mountain, so they come into the caves and mine salt from the walls using their strong tusks. Even though, just like for the elephants, salt is essential to our bodies, we need to be careful that we don't eat too much of it, because it can be unhealthy for us. Too much salt can cause problems for our heart and kidneys. People have learned to like the taste of salty foods, so it is very easy to eat too much of it. Lots of the prepared food that we buy is high in salt, and we may not even realise. Things like pizza, smoky bacon, and even breakfast cereal. In fact, just half a pizza contains 70% of our daily salt allowance. Learning how to read nutritional information on food labels is the best way to make sure you know how much salt there is in a product, so that you can choose foods that are lower in salt and keep your body happy and healthy. Salt from sea to cellar. If you have ever been to the seaside and had a swim in the sea, you'll know that seawater is very salty. In fact, this water, which comes from the Atlantic Ocean, is actually 3% salt. Here at this salt factory in Anglesey, which is an island off the northwest coast of Wales, they make sea salt by extracting it from seawater so that people can use it when cooking food. To make 2 tons of sea salt, first 20,000 litres of seawater are pumped from the sea through these pipes into this huge holding tank at the factory. Did you know that 20,000 litres is enough water to fill a swimming pool? Next, the seawater is filtered to clean it of any sand and seaweed, before it is pumped into this evaporator, where it begins to be heated up. As the seawater is heated up to boiling point, steam rises off it. The steam doesn't contain any salt, so the remaining water becomes even saltier. Once enough water has evaporated, it is pumped out of the evaporator and into the blending tank, where different batches of seawater, which are now called brine, are blended together so that they have the correct percentage of salt for the next step. The amount of salt in the brine is called its salinity. The salty brine is then pumped into these shallow tanks, which are called crystallizers. This is where the salt crystals will form. The salt harvester stirs the brine in a figure-of-8 shape like this, to ensure it is well mixed and the water in the brine evaporates evenly. As the crystals start to grow on the brine's surface, they eventually get too heavy to float and sink to the bottom of the tank. When the salt crystals have finished forming, the harvesters gently scoop out the flakes and place them in these plastic trays. Next, they rinse the crystals until the right texture and degree of sparkle is achieved. Then the piles of salt are put into low-temperature ovens to dry. A very small amount of moisture is left in the salt, because this helps to keep it crisp. When it is ready, the salt is weighed and bagged up, then packed into boxes and jars, ready to be sent all over the world for people to use when cooking their food.
So we learned that salt comes from oceans, either oceans that are on top of the earth, liquid oceans like we can go sail on, or oceans that are under the ground. But what does ocean salt taste like? How salty is it? To understand, we need to discuss a concept called salinity. Salinity is how much salt is in water. For example, I have here a measuring cup, and I have 250 milliliters of water. I'm going to pour this water in this glass. This glass has no salt in it. The salinity is 0, no salt. This is pure water, 0%. That goofy looking symbol that's got like a ramp and 2 zeros next to it, that's a percent sign. This cup right here, 0% salinity, no salt. So this 0% would be like the amount of salt in, say, I don't know, a lake. Lakes aren't salty, but oceans are salty. Well, how salty are they? Let's do an experiment to demonstrate. Here's that same amount of water. I'm going to put it in a bigger container this time. Okay, it's the same amount that's in there. It's just in a different shape. It's got about, out of this 1/4 liter, it's got about 7 grams of salt. So what does that look like? I've got a scale here and a little cup and a measuring. Let's see, that's 6. And, ooh, it's not very much, is it? Oh, that's 7. Okay, so that's about 7 grams of salt into my water. Now watch what happens. Right now the salt is sitting on the bottom. When I start to stir it up, the salt gets dissolved in the water. And if it's not a lot of salt, pretty soon the salt is kind of invisible. The water is a little cloudy right now, but give it a moment, it will kind of settle out a little bit. There's no salt on the bottom anymore. It's all in the water. I'm gonna pour that one into this cup now. There we go. All right, let's take a look. This one has got about 3% salinity. Not very much, that's oceans. My oceans have 3%. Now, you know, different oceans have different amounts, but for the sake of our experiment, the Atlantic and Pacific have about that much. Okay, so we've got 0%, we got 3%. This one's a little bit cloudier, but it's starting to settle out. We'll take a look at this. I'm gonna let that settle for a minute. However, the Atlantic and Pacific, although they're salty, are not the saltiest places. There is a sea in Israel called the Dead Sea, which is 33% salinity. 33%. Sounds like a lot. This is only 3, that's 0. 33 is more than 0 and more than 3. Let's find out how much salt that is. Okay, for this experiment, I've poured my 250 milliliters in there again, but instead of the 7 grams of salt that I put in that one, let's get this out of the way, I'm gonna put in 70 grams of salt. Wow, it's gonna be a lot of salt. Have a go at it. Okay. More. That's about 30. We're about halfway there. Put in 3 teaspoons already. Look. Okay, wow. Keep going. 65 grams. 67 grams. 69. That's pretty close. Okay, wow. Whew. That's a lot of salt. That is 70 grams of salt in the same amount of water. Oh boy, it'd be good if it was sugar, but it's not. It is salt. So there comes a point where there's so much salt in the water. Now you can see, if I hold these 2 cups up, one of them has salt in it, one doesn't. You can't tell the difference right now because it is not saturated. Saturated is when there's so much salt, say for example, in the water that the salt won't dissolve anymore. It kind of plops on the bottom instead. I don't think this is going to dissolve all the way. That's a lot of salt. I'm going to keep mixing to see what happens. Okay, here are my 3 glasses with their different amounts of salt in them, different salinities. Now, just looking at these, I can't really tell the difference. I mean, I think the one without any salt definitely looks like it's the clearest, but I still can see through all of these, and I don't see any salt on the bottom, so, they look pretty similar. Wonder how they taste. Let's give it a try for science. All right, let's start with this one. This one is 0 salinity, 0%. It's pure water. Tastes like water. Delicious. Okay. It's going to get interesting. This is our ocean, about 3.5% salinity, 3% salinity. And I don't know if you ever had ocean water. It's not going to be good. It tastes really salty. I mean, it's only 3%, but you can definitely taste the salt. I can't see the salt in there. It didn't make the water go up anymore. The salt's kind of in between the water, but you can sure taste it. Okay. I don't know if I want to drink this one. 33%. That is going to be awful. I mean, that was awful. Well, for science, I'm just going to put my tongue in it. That's really bad. Really bad. That much salt does not taste good. A really salty Dead Sea salt. Ugh. So, what did we learn from this? Saltwater tastes really bad. But we also learned that we don't drink salt water for a very good reason. It's not good for our body. The final little experiment we can do here with these glasses is I can take my super salty water. I'm going to take this one and I'm going to put it into a pan, into a saucepan, and put it on a burner. We're going to get the salt back out of it. I mean, I can't see the salt in there, so how do I get it out? I have to boil away the water. When I heat the salt water, the water starts to boil. It's going to turn into steam. The steam's going to go off into my room. The salt will be left behind because the salt does not boil. Let's do it. All right, I have here my electric burner and a saucepan and my really super salty salt. Yep, can't see any salt in there. So somehow all that salt we put in is in here. So I'm gonna just let that boil. Okay, we got a boil going here. You can see the sides of my pan already have some salt on it. It's kind of being thrown up a bit by that steam. There's steam out here. I don't know if you can see that. Maybe if I try to put a glass over the top, you can see how it fogs up. Yep, lots of steam coming out here. So we are going to just let this go. Boy, there's salt flying everywhere around here. So again, looking at this, you can see all this salt. All the salt I put in there, that 70 grams, is still in there. It didn't go anywhere. Even though when we mixed it up with the water and it dissolved, it was just kind of hiding in between the water pieces. But now that I'm taking that water out, I'm seeing the salt again. It was there all the time. It was just invisible. I think I'm running out of water here. You can see these chunks of salt on the side. There's less and less water in here to boil off. I think we're just about done. Kind of making a mess on everything. That's looking pretty good. I think, even though there's still a little bit of water left, I'm going to turn this off and I'm going to dump it onto a paper towel to dry the rest of the way. Okay, I did end up putting this in a little glass container and putting it in my oven just to speed this up. But there's no reason you couldn't. I couldn't have taken this water and just put it in a shallow pan and stick it in the sun or put it on my counter. The sun would evaporate faster than my counter, but either way, that water would evaporate and leave me with my salt again. The salt has, I've evaporated the water and the salt has recrystallized. It was a crystal, I dissolved it, and now it's recrystallized. And that is how you make salt from seawater. One more thing, I'm a little curious, how much of the salt did I actually get back out? I mean, if everything were ideal and I could get it out of my pan, a lot of it's stuck on the pan, some of it's gonna be stuck on here, I should be able to get it all back out. But I wanna take a look. So I've got my glass container here and I am going to set that back to 0. I'm gonna scrape this as best as I can. Now it's not all the way dry, so that might affect it too. I'm just gonna put it all back in there. It feels really cool, actually. Oh yeah, I'm over 70, so that's probably because it's not dry all the way. I probably took it out of the oven too soon. Right now it's sitting at almost 80, but you can see it's quite a bit of salt. Certainly just about what I put into it came back out again. It does feel different than the powdery stuff I had. If this were real salt I was gonna eat, I could just go ahead and eat this because it's just been in the clean water and then I took it out and recrystallized it. If you're gonna make this from seawater, you would have to clean it up, so you probably can't make your own salt from seawater. It's gonna be filled with a bunch of other stuff, you know, that live in the sea. Ooh. Either way, that's pretty cool. That's a cool science experiment. Let's take a moment now to talk about our different kinds of salt. Let's start with our table salt. I'm gonna sprinkle some of that right on this corner, this part. We've got kosher salt, which is a slightly bigger crystal. And I'm gonna put that over here. I shouldn't say slightly, it's actually a lot bigger. And we have our sea salt. I've taken the lid off so we can take a look at this. Okay, let's get up close and personal and take a look at these different kinds. Okay, let's take a look what we got. Here is the table salt, this fine looking one over here. The crystals are super small. This one in the middle is the kosher salt. You can see these crystals are pretty big. They look like little rocks. And this one over here, which isn't even necessarily crystally looking, it's almost flaky looking, that's our sea salt. Should I taste them and see how they taste? Again, just me here, so I'm gonna lick my finger. I'm sure they're all gonna taste salty. Tastes like salt. It's kind of crunchy. Tastes like salt. It tastes like the kind of salt you get on a pretzel. If you ever get one of those big soft pretzels and they got crunchy salt, that's what that one is. This one, it's a lot smoother. Still tastes like salt. So those are 3 different kinds of salt, and there's other kinds of salt. There's Himalayan pink salt, there's black salts, lots and lots of different specialty salts. Why would you use one over the other? It's just salt, right? Well, kind of. The 3 main salts that I have in my kitchen are the table salt, the kosher salt, and the sea salt. And you do use them for different things. This salt, the table salt, is a very small crystal, as we saw, and that's good for baking. When I'm baking cookies and pies and stuff, or breads, I do not want big chunks of salt to end up in my food. Like, ew, right? So this stuff dissolves really well in liquids. It mixes in well with batters. This is your cooking salt. Kosher salt has a much bigger grain. It's good when you're seasoning meats. So when I'm making a rub for like a steak or something, rub it on the meat, usually use kosher salt for that one. Or like I mentioned, if you want a big chunk of salt on your nice pretzel, this is a good salt for that. Our last salt is sea salt. This is a really great salt to sprinkle on your food after it comes out. Put on salads, put it on meats. This is vegetables. Because the salt is nice and big, it gives it a real good flavor and you don't need very much of it. But don't worry, if you just have this kind of salt and you sprinkle it on everything, you're fine. Tastes like salt. They all taste like salt. This is road salt. We put this kind of salt on our sidewalks and driveways to melt that ice off. In Minnesota anyway, that's where I live. It is a rock salt that is mined from the ground, like some table salt is. However, it has a lot of other stuff in there. If you remember from our video, table salt, the stuff we eat, has to go through a purification process because there's a lot of stuff under the ground besides the salt. So you don't ever want to put this stuff in your mouth. Even if you find it on the carpeting on the floor inside, looks kind of cool, don't stick it in your mouth. It's got a lot of really bad stuff in it. Poison for your body. Don't eat this kind of salt. All right, now that we got all that learning out of the way, let's get on to the good stuff. Let's make some cookies. This recipe uses sea salt and table salt, not the kosher salt. Let's do it. Cooking project time. Here's the recipe. Take a screenshot, print it out. First order of business is to combine our dry ingredients into a bowl. Our flour, our baking soda, our cocoa, and our salt. So we need 1 cup of flour, and I forgot my knife again, so I will use this thing to make sure it's smooth because we don't want to pack this in. And I'm going to level it off. I need 1 cup of flour. Plop. I need 1/3 of a cup of unsweetened baking cocoa. And this is like flour. I don't want to scoop it too hard or it's going to go flying everywhere. It's kind of hard on these sometimes. The container's smaller. So I'm going to just sort of mush that in there. There we go. Baking cocoa. And this is an experiment. We talked about sugar in our last lesson. This cocoa, which smells so good and looks so good, has no sugar in it. And if you've ever tried baking cocoa with no sugar, wow, pretty bad. So the kind of chocolate that we like to eat has sugar in it. Add some nice sweetness to it. This is very bitter, but you should try it at least once just to say you did. Next, we're going to add 1/2 a teaspoon of our baking soda. We're going to use the inside lid of this to scrape it flat. Plop. And then we're going to add 1/4 teaspoon of our regular salt, small grain salt, not sea salt, not kosher salt, none of the big stuff, just small salt, because we learned that this kind of salt is best used for cooking. All right, kind of spread them out a little bit. It's kind of fun to do that when you're doing this. See? Make some pretty designs. Then, because it's all dry stuff, we're going to use a whisk to just combine it into sort of a nice little mushy brown mess. Let's move on. Next, we're gonna put together our wet ingredients. So I've got this coconut oil. Now you could use butter, maybe even shortening. You just need a fat of some kind. I'm using coconut oil because I have it. I've got 1/2 cup of that in here. I've put it in the microwave and melted it, and I've let it cool. Turns out coconut oil gets liquidy pretty easy. So I'm gonna plop that in there. Then I'm gonna add 3/4 cups of brown sugar. Now the recipe calls for dark brown sugar. That just gives the cookies a really great color, and dark brown sugar is definitely richer, more of that molasses taste than the light brown. But I don't happen to have dark brown sugar, and it's gonna be just fine. So I don't have a 3/4 cup. They don't actually make that. But I do have a 1/4 cup, 1/4, 2/4, 3/4. 3 of those ought to do. And this one, I'm gonna pack down like a little sandcastle. Plop. Plop. And plop. Kind of soaking up the brown sugar, see? Or the oil. Isn't that funny? Okay, moving on. I need to add 1 egg, and I'm going to use a whole egg, so it's knock, knock, open the door. Knock, knock. Open the door gently. Plop. Very gentle, didn't squash the shells. No blood spots, and no shells. And it goes plop. Now I need 2 teaspoons of vanilla, and remember the cap on most vanilla, if it looks like mine, is a teaspoon. So I'm gonna save myself dishes and just use the cap. I always like the smell of vanilla. Smells good. Okay, we're ready to mix this with our electric mixer. I've combined my ingredients just with my mixer, but now I'm gonna really mix them for about 1 to 2 minutes to really get them mixed in there. Okay, it's really mixed up there. We're ready to move on. All right, I got my dry ingredients. I'm gonna add those in. Plop. And I'm gonna use my electric mixer to mix them again. You can do this with a hand spoon if you wanted to. I just happen to have my mixer out, so that works. Okay, it's done. Looks like that. Very dark. Smells kind of like coconut and vanilla. Now you could add a teaspoon of coffee at this point to give it a richer chocolate flavor. Turns out that when you add coffee to chocolate, it brings that chocolate out. Well, I don't have any coffee, so I'm not gonna do that. I'm gonna move on to my last step, and that's adding our chocolate chips. Okay, got a big bag of chocolate chips. I got my 1/4 cup again. I'm gonna put in 3 of those. 1, 2, 3, and 1 for me. And I'm gonna just use a spoon to fold them in. Suppose you could use the electric mixer, but you don't need to. Actually, this batter's pretty thick. It's almost like brownie batter. You can see it kind of, it's not runny, which cookies shouldn't be. Okay, got those mixed in. Suppose you could add M&Ms, that would be good. Or what about white chocolate? That could be good too. This recipe has possibilities. But I'm gonna stick with the chocolate chips just to start off with. Okay, I think we're ready to put these on the pan. All right, I'm gonna take my dough, which is kind of oily because of that coconut stuff. Take about a ping pong ball size, roll it into a circle, plop it on the pan, and then I'm just gonna kind of flatten it a little bit, like that, okay? And I'm gonna do that to all the rest of my dough. Okay, they're done. I got about 18 cookies out of this. Boy, that's pretty greasy. All right, I'm gonna put these at 350 for about 8 to 10 minutes. And when I pull them out, I am going to immediately put some of my, while they're still kind of hot and gushy, I'm gonna grind some of this nice large crystal sea salt onto them. The chocolate and the sea salt, sweet and kind of salty, good flavor. Let's do it. Into the oven they go. Okay, the cookies are done. They look good. They didn't really spread out anymore once they baked. I think probably because the coconut oil was already liquefied, so you can put them pretty close together. Let's see how close mine are. And I don't know if you can see, but I did sprinkle the salt on there after they came out, so they're kind of crystally on top. Let's try this one. They're soft like a brownie. Ooh, there's chocolate leaking out of that one. Ooh, I can taste the salt on there. I may have put a little too much salt on top. Note to self, maybe 1 sprinkle. They're kind of salty. They're good though. I think that adding that little bit of coffee like the recipe calls for would go a long way in really making these super, super dense chocolate. Plus, I'm sure the dark brown sugar would have given it a little heartier flavor too, but I gotta say, these are really good. It's a lot like a brownie. I don't know if you can see inside of there. It's pretty chewy. Falling apart. Oops. Yum. Yep. Well, this is a definite thumbs up. Well, that's all I have on salt. Another cool kitchen chemistry item. Kitchen chemistry is so cool, and science is cool.